Alright, so our last section in Chapter 4 is over linear functions. And actually the coolest part about linear functions is that there's really no new information. It's all old information that we look at in a slightly new way. So, you have seen linear functions written in the form y equals mx plus b. We're really familiar with slope-intercept form. Excuse me. But we can actually take out the y and put in function format, which means that we're going to name it f. And we're going to use this notation right here. Function notation says f of x. So it's a function that has x as its variable. Now we could name our function any letter we want. Usually f, g's, and h's are the most normal ways to see it. So that if I see y equals 3x plus 5, it's the exact same thing as saying 3x plus 5 is equal to f of x. So, a couple of things that we're going to do with this. The first is evaluate the function. Remember that the word evaluate tells us that we're going to get an answer. We're going to have a number at the bottom. The function f of x equal to 2x plus 1 when x is equal to 3. The notation looks like this. We write the original function the way it was, and because they asked me to plug 3's in for x's, I need to do that everywhere. So f of 3 equals 2, remember we're taking x's out and putting 3's in, plus 1. 2 times 3 is 6, and 6 plus 1 is 7. So that f of 3 is equal to 7. I want you to notice that this f of 3, all of this function notation, we don't ever do anything with it. It's just notation. This tells me that I went into the function named Frank, I plugged in 3's in place of the variable, and the result was 7. Or if they asked me to graph it, I could say that the ordered pair, I plugged in 3, input or x or domain, and I had an output of 7. Now let's practice it. F of x equals 15x plus 4 when x is equal to negative 3, 0, and 2. So we're going to do 3 different problems. We're going to do f of negative 3. So go into the function and replace the x's with negative 3's. So 15 times negative 3 plus 4. Bring that notation down, f of negative 3. So it was a function, we plugged in negative 3. And I'm going to do it in 2 steps. 15 times negative 3 is negative 45 plus 4. So that f of negative 3 is equal to negative 41. And that's all I have to do for that problem. Now let's do the next piece, because it asks us to do 3 values for x. Let's do f of 0 and f of 2. We need to do f of 0, and you need to do f of 2. Give them a try, and then come back and check your work. Okay, so hopefully you checked over your work. And again, I just showed you an ordered pair. It didn't ask us to graph. So we really would just need to list negative 41, 4, and 34 as our 3 values. Let's go to example 2. For the function f of x is equal to negative 3x plus 2, find the value of x so that f of x is equal to negative 13. So now we're going backwards. We want to find out what got plugged in. So we have to take f of x out and put the negative 13 in. So we write our problem down. We take the function notation out and put the negative 13 in. And then it becomes a two-step equation that we can do pretty easily. We subtract 2 from both sides so that negative 15 equals negative 3x. Divide both sides by negative 3 so that positive 5 is equal to x. So when x is equal to 5, f of x equals negative 13. Or we might also write the function notation as f of 5, because remember that's what we plugged in, is equal to negative 13. I'm going to do h of x with you, and you do f of x without me. So let's practice one together. It says, find the value of x so the function has the given value. H of x is equal to 4x minus 2, and I want to know what happens when h of x is equal to 18. Alright, so let's go ahead and plug it in. Remember, we're taking h of x out and putting 18 in. And now I have a two-step equation to solve. Add 2 to both sides. 18 plus 2 is 20. And 4x minus 2 plus 2, well, that's just 4x. Divide both sides by 4. So I get 1x is equal to 5. Now, I didn't show all of my steps because some of you are ready to start skipping and not showing all of your work. And I wanted to show you what minimum work would look like. I need to see what happened after you added 2, what happened after you divided by 4. But I don't necessarily need to see every step. You're welcome to show any step along the way, all of the steps, some of your work, whatever makes you most comfortable. But this is the minimum I need to see in a problem like this. I'm going to go ahead and do f of x. You show as much work as you would like. I'm going to show all my work when I do f of x. Alright, I hope you got that last problem, and Elizabeth and Jacob and I are going to go eat some breakfast, and hopefully I'll get the rest of this video recorded later tonight. So, have a good one. Bye.
Bye.
Say bye.
Bye.
Say, go do your homework.
Go do your homework. Get on work now.
You're crazy, Elizabeth. We love you.